Let's look at this question on the board. Calculate the mass of sodium trioxide 5 produced when 30 grams of pure sodium hydroxide reacts with 100 cl cube of 1 molar trioxide 5 acid. Questions like this can throw you off balance. It can throw you off balance because you look at it. Calculate the mass of sodium trioxide 5 when 30 grams of pure sodium hydroxide reacts with 100 cl cube of 1 molar HNO3. All these are participants in the reaction. So which one do you relate to what? That is why it must throw you off balance. And this is how to do it. Now, first thing first, in stoichiometry, it is important that you must write balance chemical equation first. So now, what is the balance chemical equation? Calculate the mass of sodium trioxide 5 produced. That it means that NaNO3 is a product. When what? 30 grams of pure sodium reacts with 100 cl of 1 molar HNO3. So it is an acid HNO3 reacting with a pure sample of sodium hydroxide. Good. Now, in our basic chemistry, we said that when an acid reacts with a base, we are getting what? A salt and what? A water as the only product. So now the salt here will be what? The sodium nitrate and what? Water. So check whether it's balanced. 2, hydrogen is 2, nitrogen is 1, oxygen is 3 plus 1, 4, 3 plus 1, 4, sodium is 1. So the equation is what? Balanced. Good. Now, what are you given? We are asked to look for the mass of what? Calculate mass of NaNO3. That is our focus point. When what? 30 cl cube of pure, so mass of NaOH is what? 30 grams. Reacts with 100 cl cube of what? 100 cl cube of so volume of what? Of acid is equal to what? 100 cm cube. Okay, then concentration of acid is what? 1 molar or 1 mole per dm cube. So that is that. So we have all this. We are looking for this. This is what we are looking for. Now it is left for us to now determine these two reagents. Which of them is in excess and which of them is a limiting reagent? Because this is a theory question. So this is a theory question. Why? So you must be very careful. Your steps will show what you're doing. Is this why you don't want to do shortcut? Now, these are two reactants. Which of them is limiting and which of them is excess? I will say that the limiting reagent controls the reaction. Are you following? So in stoichiometry, we normally ignore the excess reagent. So how do we get the limiting reagent? Let's look at what we are given. We are provided with what? The mass of this, and we are given what? The volume and what? Concentration of this. So we can actually relate them. So first of all, let's get the number of moles from the mass of this. We said that N is equal to mass over molar mass. So now, the mass of this was provided. What's the molar mass? Molar mass of sodium hydroxide. So molar mass of what? NaOH is equal to what? This is 23. This is 20. So that's 23 plus 16 plus what? 1 will give us 40 grams per mole. Right? That's molar mass of sodium hydroxide. So we can now say that number of moles of sodium hydroxide will be equal to what? The mass, which is 30 over 40 will give us what? 30 over 40 should give us 0.75 mole. 0.75 mole of this is the mole of sodium hydroxide. Now let's get the mole of what? Of the acid. Okay. Now what relation do we use? Knowing that we are giving volume, we are giving concentration. We know that N equal to what? Concentration times what? Volume. Is that clear? But you should also know that you're converting this volume to what? To mole per to dm cube rather. So what do you do? Remember that 1000 cm cube is equal to what? 1 dm cube. Note that. Then 100 will be equal to what? 0.1 dm cube. Simple. So in conversion, 100 cm cube is equivalent to what? 0.1 dm cube. So now we can now say NaHNO3 will be equal to what? Concentration is 1 times what? Volume. 0.1. So we are getting what? 0.1 mole. So now let's look at what? Which of them is limiting and which of them is excess. So this is that. NNOH, number of moles of NaOH is what? 0.75 mole. NHNO3 is what? 0.1 mole. So because the mole ratio now, the mole ratio of this to this is 1:1 now. I see 1:1. So it means they have equal mole ratio. So now comparing which of them is smaller. So this is the smallest. So sodium hydroxide is in excess. So we work with what? Nitric acid. Now let's go ahead and solve now. Let's read it. So from the equation, 1 mole of HNO3 gave us what? 1 mole of NaNO3. Are you following? Now 0.1 mole of what? HNO3 will give us what? 0.1 times 1 mole NaNO3. It's still more ratio now. So this is what? 0.1 mole NaNO3. But is that what we are looking for? No, we are looking for what? The mass. So it's time also to convert this to mass. Are you following? By now calculating molar mass of this. So molar mass of NaNO3 is equal to what? This is 23 plus what? Plus 14 plus 16 times 3. So this is equal to 23 plus 14 plus 48. Let's confirm that 16 times 3 48. Yes. So 23 plus 14 plus 48 is giving us 85. So 85 grams per mole is the molar mass. Okay. Now, what are we doing now? We know that N is equal to mass over molar mass, right? Good. We are looking for mass. So mass will be equal to what? N times what? Molar mass. This is still very simple. So M will be equal to what? 0.1 times what? 85. So 0.1 times 85 will give us what? 8.5 grams of what? NaNO3. So that is the answer to the